Good morning, everyone. This is a budget power supply, the Rosewill S400A01-Z. It comes from a budget case from Newegg. Rosewill is the house brand of Newegg. For $60 with a case. It's 400 watts, 336 on the 12-volt rail. It's a perspective piece component of BOINC Folding at Home Distributed Computing for Cancer Computer 2.0 project. At the end of the decade or something, I'm going to be testing this power supply to see how it holds up. I have a couple of windshield 12-volt heaters, and I also have a Peltier I can use to load this 12-volt rail, and we will see how it does thermally and holding up the voltage over time. We'll see if this is any sort of durability for high load, sustained high load, high temperature. And now let me see if this fan is replaceable and what type of fan it comes with. Probably a cheap sleeve fan. I need something that will last a long time, such as the Thermalright TLB12 Extreme. Sleeve 0.25 amps. That might have decent airflow, but it's definitely kind of looks like an airflow optimized instead of a static pressure. I'm not a big expert on propeller design, but you see the gap. But decent amperage, but I questioned the long term because the sleeve. Let's look. Is it? Oh, look, it's socketed. You know, at 2-pin. Oh, I have to adapt the 4-pin to a 2-pin. But at least it's not soldered. I can replace it. And it's standard thickness, 120 mil. Has decent heat sinks. I don't know much about the manufacturers of these components, but this is what you get with like a $20 power supply. What do you have? What don't you have? I do believe I read that it has a variable speed fan. Well, not with 2 wires. Well, we'll see. Maybe voltage controlled. No load voltage. Fan speed low. It may be variable speed despite 2 pins, so voltage controlled. We'll see if this fan spins up. Right now it's barely moving any air. This very old, slightly fried power supply, about 240 watts at the wall, been going down as the Peltier heats up, plus fans. Power factor about 0.63. Let's see how the new power supply works out. Let's see. I have it all connected up through an extension. Hot and cold, or positive negative. Through the ATX, I will also use probably this for the windshield heater or a Molex. Let's see. No smoke. Slightly less wattage than the ancient power supply, so that's a good sign. It's slightly more efficient. I'd say about same temperatures, about 15 watts less power consumption. So it's a step up from this old one where most of the power rail is 5 volts instead of 12, so that means it's really old. Power factor, let's see. Does this have active power factor? No. 0.69, just about like the other, 0.63, 0.69, so no PFC. Spin faster. I want to say this is spinning faster, based on load instead of temperature alone. We'll see. Let me put my ear to it. Let me just say, this ancient Comair Rotron fan for IBM, probably back in the 90s, it moves almost as much air as the TLB-12 Extreme. Both about the same amperage rating, both ball bearing. It's just kind of interesting how, well, a fan is a fan after all. You hear that it's about the same rotation speed. Lots of torque. Pulling 330 watts. Fan seized with the zip tie. It is variable speed, definitely. And it does not have an anti-stall feature. It keeps on, it doesn't do a tick-tick. It keeps on applying torque continuously on this fan. It's just a cheaper fan. But, you release it, it is going full speed now. This reads about 0.15 volts lower than the power supply tester. You know, it's actually a percentage, but it has dipped quite a bit. 11.7 volts equivalent or so. Now let's turn off the windshield heater. Now it is 11.85 or so. So it dips quite a bit. And that is despite it being less than fully loaded. According to 12 volt, it's supposed to handle 336 watts on the 12 volt rail. Now, the only thing might be that this lead particular is joining in with the Molex connector or one of the others, and this isn't actually the rail on the power supply, because I don't know how it is internally wired. And that voltage reading is with the fan blocked and about 130 degrees heat output of the power supply. Let's see if voltage output improves with proper airflow. Airflow about 105 degrees exhaust. Voltage is essentially the same, a couple 100ths of a voltage higher, that's all. However, this is within ATX 2.0 tolerance, 11.4 to 12.6 volts. I read is acceptable. This clamp meter reads the same as that one basically, so we can trust it now. So there you go, under full load, 11.55-ish volts. Technically within spec. So in rush, about 14 amps. I tried both on the black and the white. Green is ground. It maxes out about 14.5 amps. On the other one, I with more hands available, I tried to center it better. So it looks like about 15 amps in rush. It's nothing crazy, which is a really good sign for having 4 of these or more on a circuit. Probably 4. Well, it has held up to the durability test. High thermal stress event. It could be reliable if I replace the sleeve fan with the ball bearing fan. However, due to its lack of power factor correction, which is essential, and relatively loose 12 volt rail, even though it held up well under high sustained load, it doesn't have very tight voltage regulation. And who knows if it degrades, if it will get worse. It could be reliable and good, but no active power factor correction is essential. It puts more strain on the household circuits and the grid, which is a priority for me. I will be probably going with a Be Quiet latest Be Quiet 650 watt version. That seems to be the sweet spot between 550, 650, 750. That seems to be the best deal, and I will probably test it in this rig here and see how it compares.